Alright guys, welcome to our third video on dynamics, also known as forces. Okay, so in forces, first we look at the forces in one dimension. If you've got two forces unequal, the resultant force will be 5 minus 3, 2 newtons. So since it's not zero, we say that forces are unbalanced. And what about the other case here? The other case here will be forces are balanced because both sides are the same, so it's 0 newtons, forces are balanced. So what's the effect of balanced and unbalanced forces? Okay, if forces are unbalanced, that means if one side is more than the other, okay, your body will either accelerate or decelerate. Okay, whereas if the forces are balanced, okay, it will only either be at rest or moving at constant speed. Okay, why is all this important? Okay, it is because of this formula here. F equals ma, where m is a mass, a acceleration, and rf is not really any force, but it's the resultant force over here. Okay, so how do we calculate the resultant force? Okay, resultant force calculate using all this by looking left or right. Okay, just before we go straight into this, there's a couple of scenarios. Just a couple of definitions here. Friction is the contact force or the opposite motion, and pressure is the force exerted per unit area of this formula here. Okay, so like what I said just now, for a constant mass, okay, you can actually have two scenarios. It can give you a resultant force. You can actually find the acceleration. But if I give you the acceleration, you can actually find the resultant force. Okay, so looking at this is a scenario. Given forces, find acceleration. The other one is given acceleration, find the force. Okay, so for a car of the mass 1,500 kilograms in the first scenario here, for case A, you can see what's first thing? What's the resultant force? 5,000 to the right, 2,000 newtons to the left, so it's 3,000 newtons to the right. I can conclude, since there's a resultant force, it's accelerating, right? And how do I calculate the acceleration? Yes, I use the resultant force here. I don't use 5,000, neither do I use 2,000. I use 3,000 as the resultant force. So 3,000 F over M, which is 1.1005 over here. See, I given the forces, I can find the acceleration. The other scenario too is given the acceleration, they tell you the car is accelerating at 2 meters per second square. Can you find first what's the resultant force? Yes, but of course, most of the time they won't really ask you the resultant force. You know what they'll do? They will ask you, um, given a forward driving force of a certain amount, in this case with 5,000 newtons, what is the friction? Okay, so you can tell friction, the rest is just mathematics. You can actually divide it and find the friction of 2,000. Why? Because if I were to put a friction of 2,000, it will give me a resultant force of 3,000 newtons here. Okay, all right, what about the next case? Next case, case B is similar. Okay, so over here, except rather than accelerating, it's actually decelerating. So I can also find the deceleration here, right? Okay, over here in this case, given a acceleration is 5 meters per second square, I can first find F equals ma 7,005 is the acceleration, right? Oh, sorry, it's the resultant force, right? So since it's the resultant force, what's happened? I can actually use the formula for resultant force equals to forward minus backwards. And the rest is just maths, basically. Okay, so I can find the driving force is 8,000 newtons here. Okay, case C is most interesting. Okay, basically over here, if I see what's the resultant force, 5,000 to the right and 5,000 newtons to the left, or rather forwards and backwards, zero resultant force, right? Zero resultant force from the equation F equals ma. F is zero, acceleration must be zero, so it means it's at constant speed. Okay. What about this case here? In other words, the converse is also true. If they tell you a car is moving at constant speed, straight away, you can tell that the resultant force is zero. Okay, so if they give you a forward driving force of 7,000 newtons, you can straight away also say friction force is 7,000 newtons. All right, hope you enjoyed this part, chapter 3. Okay, I'll see you in the next.